Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the second chapter of grade 8 mathematics and the name of the chapter is Exponents and Powers. Okay students, so let us first of all see what are the different topics we are going to cover under this chapter. So the different topics will be, we will first recall what is an exponent. Then we will proceed to negative integer exponent. Yes, a new topic that will be introduced in this chapter. Then we'll see what are the different laws of exponents that we have already understood, but we'll apply it here also. The next topic will be expressing very small numbers using exponents, and then we'll see how to write expanded form of a number using exponents. Yes, and the last will be comparing very large and very big numbers or very small numbers using exponents. Okay, starting with the first topic, positive integral exponent of a rational number. In our previous class, we already know how to express when a number is multiplied by itself using exponents. Like if write 2 raised to the power of 4, it means 2 is multiplied with itself 3 times. Yes. Now, same is applied when we have exponent and base as a rational number. So here the 2 is called base and 4 is called exponent. Now, if we have a rational number 2 over 9, let's suppose, and if it is multiplied with itself 3 more times, then we can write it as 2 over 9 raised to the power of 4. It means 2 over 9 is multiplied 4 times, and we can also say 2 over 9 is multiplied by itself 3 times. Okay, now here 2 over 9 will be the base and 4 will be the exponent. So the rule and the law that we have already covered about the multiplication of same number again and again is also applied to rational numbers also. Okay, so here we have, if a over b raised to the power of n is written, then we can multiply a over b n times. Yes, and we can write it as like this: a over b raised to the power of n is equals to a raised to the power of n over b raised to the power of n, where n is any positive integer. The notation of writing the product of a rational number by itself several times is called the exponential notation or power notation of the number. Next topic, negative integer exponent, students. So in this, the exponent n with base a is negative. Like, let's suppose if we take a rational number 2 over 3, because we all learn exponents or negative exponents on rational numbers only in this chapter. So let's suppose if we have an exponent negative 6, then how we can deal with it. So here we'll see how we can express or simplify negative integers exponent. Yes, so there is a rule which says if there is a negative exponent over a base, I am taking a rational number, and if something is in the exponent as a negative, we have to take the reciprocal of the number. So let's suppose if we have 2 over 3 and it is raised to the power of 6. So in order to simplify it, we have to take the reciprocal of the number 3 over 2 raised to the power of 6. And on simplification, we will get our answer as 3 raised to the power of 6 and 2 raised to the power of 6. As these are very big numbers, we will not simplify it further. Yes. So it means if there is a rational number a over b, yes, in the form of p over q or a over v, and there is an exponent that is negative exponent, then we have to take reciprocal to make the exponent positive. Yes, student. So we have to take the reciprocal of the base, and we can write the negative exponent as a positive exponent. Yes. So here is a derivation of how we reach to this point, that why we should take a reciprocal of the base. So you can go through it, understand how this negative exponent can be converted into a positive exponent by taking reciprocal of the rational number. But students, let's suppose if we have a rational number where there is no denominator like this, then simply if there is no denominator, it means denominator is 1. So we can reciprocal the base as 1 over 3 and we can write it as 6. So this will be quite easier to deal with negative exponent by converting the base into its reciprocal. Clear? And then changing the negative exponent to same value of positive exponent. Clear? Now, so next is 0 as an exponent. So students, when something is written with exponent 0, any rational number if written with exponent 0, then the answer is 1 always. Okay, so let's suppose if we have 4 over 5 and exponent is 0, then the answer is 1 only. So it is valid for any rational number where denominator should not be 0, because it will not be a rational number. Yes. Now let's take one example. Example number 6. Example number 6 says, by what number should this 3 over 4 raised to the power of negative 3 be divided so that the quotient becomes 1 over 27. So students, we always take the missing value as x or a. So let's suppose the missing value is x. Now the statement says that what should be divided. So we can write that x should be divided like this and the result should be 1 over 27. Now if we simplify it, first of all we have to convert this negative exponent to positive exponent. In any problem, first step is to convert negative exponent to positive exponent. So here we'll have 4 over 3 raised to the power of positive 3. Yes. Now where we have divided by x is equals to 1 over 27. Now student, what we can do is we can just shift this over here, and we can also, first of all, there are two methods that we can follow. First of all, either we can convert this division into multiplication, or we can just transfer this to this side. Yes. So if we change the division to multiplication, it will look like this: 4 over 3 raised to the power of 3 multiplied by 1 over x, and here we will have 1 over 27. Yes. Now in order to find x will go to the right hand side and 1 over 27 will go left hand side. So moving forward, if we have 4 over 3 raised to the power of 3 divided by, because here we have, or multiplied by 27, let's take directly. If we multiply 27, because it will, if I will cross multiply, the 27 will come over here and x will go over here, which will become x only, because x times 1 is x only. Now solving this will be 64 over 27 times 27 is equals to x. 27 and 27 will cancel it out and 64 will be the final answer. So the basic is you have to convert negative exponent to positive exponent and then follow the pattern that we have already understood in the previous grades. Yes students. Now moving to the next topic, laws of exponent. Students, we have already covered laws of exponent in our previous grades, and we know that laws of exponents makes us easier to deal with exponent. Same laws of exponent that we have already understood will be applied with negative integer exponents also. So let us see. So for that we have 5 laws: law 1, law 2, law 3, and there are extension of laws which are considered as law 4 and law 5. So first law says, if a over b is any rational number and m and n are two integers, then we have this expression, that is, if bases are same and they are in the form of multiplication, then we can write the base one time and then we can add exponent like this. So this is the first law. And if we take one example, let's suppose if we have 2 over 3 raised to the power of 6 times 2 over 3 raised to the power of 4, what we can do is we can write 2 over 3 raised to the power of 6 plus 4. So final answer will be 2 over 3 raised to the power of 10. Students, same law can be applied to negative exponents also. Let's suppose if we have negative 3 over 2 raised to the power of negative 5 multiplied by negative 3 by 2 raised to the power of, let's suppose, negative 8, then there are two methods. Either we convert this negative exponent first into positive exponent, or directly apply the laws of exponent and then apply the rule of converting negative exponent to positive exponent in the final answer. Yes. So we can write out negative 3 over 2 raised to the power of negative 5 plus negative 8, which will give us negative 3 over 2 raised to the power of negative 13. Now to write the final answer, always represent the expression or rational number using positive exponents. So we can write it like this: negative 2 over 3 raised to the power of 13. So laws makes us easier to deal with exponent. Yes, students. Now moving to the law 2, which is if a by b is any rational numbers and m and n are two integers, then we have this rule. Yes, students. So we know that how to multiply same bases with either positive exponent or negative exponent. Similarly, if we have same base, but instead of multiplication as operation, if we have division and the bases are same but exponents are different or same, it doesn't matter, the bases are same is the main thing that we have to look out, then we have to subtract the second exponent from the first exponent like this. Yes, so it is quite similar to the first law, but here instead of addition we do subtraction. Let's suppose if we have negative 6 over 5 raised to the power of negative 2 divided by negative 6 over 5 raised to the power of negative 3 or positive 3, any exponent can be there. Now we can write the base one time, negative 6 over 5, and we can have minus 2 minus of minus 3, which will give us negative 6 over 5 raised to the power of positive 1. Now we don't have to take reciprocal as the exponent is already positive. Yes, so this is the law 2. Law 3. Law 3 says if a by b is any rational number such that a by b or a over b should not be 0 in any law. Yes, and m and n are two integers, then we have a rule where we have to do the product of the exponents whenever the product is present over the bracket and inside the bracket also. Then to simplify this we have to multiply the exponent. Yes, so power of powers rule, this is called powers of power rules. First was rule of product, and second was quotient rule, and the third one is powers of powers rule. So they have special names depending upon their expression. Yes. Next, moving to the next topic, that is extension of laws of exponent. Student, it is nothing but the extension of the topic that we are doing before, which was laws of exponent. So here instead of bases, the exponents are considered as same. So if we have different base like a over b and the exponents are same, raised to the power of m multiplied by another base c over d, but the exponents are same, then we can write the multiplication of rational number first and then we can have a single power over here. So this is the rule or law number 4, and the fifth law is the opposite of multiplication, that is division. Instead of having multiplication, if there is division in between two rational numbers with same exponent but bases are different, then we can have first of all the division part of the two rational number and then a single exponent to represent the final answer. Yes, so and after that you can just solve it, right? We know that how to divide two rational numbers, that we have already covered in our previous grade. Yes, so let's take one example. Example number 14. Simplify the following. So we have first as negative 3 over 5 raised to the power of 3 multiplied by negative 1 over 4 raised to the power of 3. So here bases are different but the powers are same or exponents are same. So we can write negative 3 over 5 raised to the power of 3 times negative 1 over 4 raised to the power of 3. Now we can multiply the rational numbers first and then we can have a single exponent over here. Yes, so this will be 3 over 20 raised to the power of 3. So it doesn't matter the exponent are either positive or negative, just they have to be same, and then we can apply these laws. Yes. Now moving to the next topic, that is use of exponents to express small numbers in standard form. Students, we have already covered in the previous grade that how to represent very big numbers using exponents, where we use the expression 2.3. I am giving you an example that we have used the expression like 2.3 times 10 raised to the power of 5. always we have to write the decimal after the first digit while expressing them in the standard form. Yes, so this expression, if we call it a, and this expression can be called as 10 raised to the power of n, here a should be between 1 to 10. It can't be 10, but it should be between 1 to 10, like 1.2, 2.3, 2.4, 7.8. It can be anything, but it can't be 10 or more than 10. So we already know how to do it. Let's recall by taking one example. Let's suppose if we have 2, 3, 4, 5, 6, 1, 2, 8. Now this is very large number, so we need to represent them in the standard form so that we can deal with them easily. Yes, so we have to place decimal after first digit, that is 2, and we'll write it as 3, 4, 5, 6, 1, 2, 8, and we'll write times 10 raised to the power of. Now the exponents depend upon how much the decimal is shifted to its left in the case of large numbers. So here there is no decimal, so we'll consider it over here. Now how much digits we have to move to shift the decimal from this point to the point there a decimal is present now? Yes, so this is 1, 2, 3, 4, 5, 6, 7. So 7 will be the power of the, or exponent. Will not say power, we always confuse with the term power and exponent. Power is the expression that we have as a 10 raised to the power of something, and exponent is the value that we are writing on the top of the number. Yes, so this is the standard form or scientific form of very large numbers that we have already covered. Now let's take example. Let's suppose if we have any decimal already present over there and we have to convert it into standard form or scientific form. So what we can do is we again write a decimal after first number like this, and then we'll see how much the decimal is shifted to its left. So this is 1, 2, 3. So we'll write 10 raised to the power of positive 3. So this is the method that we have already covered. Now we'll apply the same logic to very small numbers, and we'll see how to represent very small numbers using exponents. Yes, there is quite similar pattern in representing these small numbers using exponents, but here the exponents become negative. Let's see why. So the rule is same. We have to write in the form a times 10 raised to the power of n, where n will be negative and a will be between 1 to 10, where it can be 1 but it can't be 10, it should be less than 10. Yes, now how we can do it? So let's suppose if we have very small numbers 0.0023446, then the rule is same, that we have to shift the decimal to the first number that we have. So the first number in this is 2. So we'll shift this decimal over here and we'll have 2.346. Now again 10 raised to the power of what? So now the decimal is shifted to the right of it. Yes, so we have to write the number with negative value, like we shifted this decimal from this point 1, 2, 3, 4. So we'll write -4 over here. So the conclusion is, if we shift a decimal from right side to left side, the exponent over 10 is always positive. But if we shift a decimal from left side to right side, then the expression have a negative exponent. But the rule or the method of finding out the value of n remains same, that how much is decimal shifted from its original position to the new position. Clear, students? Now the next topic is expanded form using exponents. Students, we already know what is an expanded form. So expanded form is representing a number using its place value, where each digit has been added with its place value like this. Let's suppose if we have 264 over 3. Now place value of 2 is 2000, and then place value of 6 is 600, then place value of 4 is 40, and 3 is 3. So if we write like this, then this expression is called expanded form of the number. Now we'll see how we can represent very large or very big numbers using exponent. Yes, so if we have very large number, let's suppose if we have a number like 62345.621, this is very large numbers. Now if you want to represent it using expanded form, first of all write its expanded form like this: 6, and how many zeros we have to do? 1 2 3 4 zeros we have to write, then 3 zeros will be there, then there will be 2 zeros, then there will be 1 zero, then there will be no zeros, then there will be division by 10, then there will be division by 100, and there will be division by 1000. We have already understood it in the decimal expansion. Yes, now in order to represent 10, we use the expression 10 raised to the power of 1. In order to represent number 100, we can use the expression 10 raised to the power of 2. Yes, similarly, depending upon the number of zeros we have in the multiples of 10, like 10, 100, 1000, 10,000, lakh, we use the exponent on the base 10. Yes, so here we'll write 6 times 10 raised to the power of 4 because we have 4 zeros. Here we'll write 2 times 1000, which will be 10 raised to the power of 3. Then we will have 3 times 10 raised to the power of 2. Then we'll have 4 times 10 raised to the power of 1. Then we'll have 5 times 10 raised to the power of 0, plus 6 times 10 raised to the power of -1, because expressions like 1 over 10 is written as 10 over -1. The power is raised to -1. Yes, then 1 over 100 is written like 10 raised to the power of -2. So similarly, instead of positive exponent, we use negative exponent to represent these kind of numbers. Yes, now next is, after this we have 2 times 10 raised to the power of -2, and then 1 times 10 raised to the power of -3. So this is the expression that we have used to represent the number 62,345. So this is quite easy, just you have to write the normal expanded form that we already know. Then for each place value or each number, we have to use exponents with the base 10. So here are some examples that you can go through and understand it in a better way. Students, moving to the next topic, comparing very large and very small numbers. So student, it is very difficult or very confusing to compare two large or two small numbers. So there is a rule using exponent that makes it easier to compare. Let's take an example. Example number 19 says, compare the diameter of Earth, which is 1.2756 times 10 raised to the power of 7 with the diameter of Sun, which is 1.4 times 10 raised to the power of 9. Student, now these numbers are difficult to compare. So first of all, we have to write it in such a way that the exponent on the base 10 should be same for both. So either we'll convert 1.2756 times 10 raised to the power of 7 with exponent 9, or we have to convert the exponent 9 to 7. So it's all depends upon you what you want to do. So let's suppose if we want to convert 10 raised to the power of 7 to 10 raised to the power of 9, what do we need? So we need 10 raised to the power of 2 so that we can multiply it and the sum of the exponent become 9. So in order to cancel out the operation, we can write division of 10 raised to the power of 2 below it. Yes. Now if it become this, then we can use this to shift the decimal to the left side of the digit that we have. Yes, so we have 1.275 times 10 raised to the power of 9, but there will be 10 raised to the power of 2 in the denominator. Now this will make this to form a number like this, 0.01275 times 10 raised to the power of 9. Yes, and I can see that this is 1.4 times 10 raised to the power of 9 and this is 0.01275 times 10 raised to the power of 9. When bases are same on the when the exponents are same on the base 10, then in that case we have to compare the first part only. So here we can see that 1.4 is bigger. So it means the diameter of sun is bigger than the diameter of earth, and we can find out how much is it bigger. So for that, what we can do is we can write the expression of the sun over the numerator, and we can divide it with the value of the diameter of earth, which is around 1.2756 times 10 raised to the power of 7. Now they are quite same, yes, because we can't find the decimal value using division in a faster way, so we use approx method to get the value, because we write the approx value always if we don't have the exact value, yes, in these scenarios. Now if we divide this, it is quite similar value or same value approximately, so we'll write 1 over here, and here we'll use the laws of exponent to write 9 minus 7, because the bases are same and exponents can be subtracted. So we can write it over here like 10 raised to the power of 2, which is 100. It means the diameter of sun is 100 times the diameter of earth. So student, in this way we can compare two very small or very large numbers by making the exponents same, or by dividing. If we have to compare the diameter or any size or any length, then we can also find the ratio to see how it goes, yes. So it can be done in any way, either we say the ratio or we say how much or which one is greater. So it's all depend upon you or the assumption that you want to make. Okay, so students, this is all from this video. I hope you have liked the video and understood the concept very well. We'll meet in the next video. Till then, keep practicing, keep learning.